All right, Lexi, so we're looking at lesson 65, number 23. You notice that there is a triangular diagram here with some given information. You notice that there are also some lines drawn from a couple of the vertices to its opposite side. So let's discuss what we see here first. All right, so we are given some information. We're told that GI and FH, so identify those, GI and FH. Are altitudes. So remember what an altitude is. If you think about flying on an airplane and you're always questioning, what is the altitude now? My ears are popping or whatever. It means height, like how high are you? So altitude is height. How tall your triangle is from a vertice to the bottom, the opposite side of that, not vertice, vertex, the opposite side of that vertex. Okay, but it means height, so keep that in mind. So we see those altitudes drawn to the opposite side there. We're also told that angle HGF. Okay, so what I'm noticing here is we have a couple of different triangles. So I'm going to try to shadow those in a little bit just to be able to see them. Oh wait, let me get rid of the these altitudes real quick so that we can kind of color out these two. And we'll do one pink. And actually, let's do, I guess pink is okay. So you see that triangle there, and then you also see this triangle here. Okay, so we've got two triangles. So my guess is we're going to probably be using that whole theory of proving three corresponding parts of the triangles congruent. Let's see where we're headed in this. I'm going to go ahead and erase at least the one out of there and see what else we have. So HGF, let's go back to that. HGF, which is right here in this yellow triangle, is congruent to IHG. IHG in this triangle. Okay, so can you see that? And actually off to the side over here, I actually pulled out the triangles so you could see them a little better. I tried to draw them as you see them on there. I didn't do the best job, but you see that this angle here, no wait, not that one. Let me see which it is. It's angle G. This one here is actually congruent to this one here. Okay, so I'm doing this so that we can show that we have three equal parts. Where are we heading here? We're trying to prove that GI, so we're trying to prove that this side right over here, and I'm going to put a highlight on it, that GI and FH are congruent. So you can notice if I were to turn this triangle, keep turning it till it was sitting on its base and then flipping it over, it would be in the same position as the other triangle. But right now they're not lined up exactly the same way, so it's kind of hard to see that. So we're going to work through this and prove some parts congruent. So let's start with number one. Number one is simply the given information that we've already read. So go ahead and fill that in. Step two, because of the altitudes that are coming down, I had those marked in yellow just a moment ago. These altitudes that are identifying the height of the triangle, the great big triangle under there, DGH, the great big, the whole triangle, those altitudes are identifying height from one vertex to its opposite side. So if I turn that triangle from base to base to base, then you'd be measuring the altitude of the triangle in every position that it can sit. Okay, so look at step number two. Because of the altitudes, and remember, if an altitude comes straight down from a vertex to its opposite side, it's creating right angles. And I'm going to draw those in here. And then I'm going to go over and draw those in to the ones that I pulled out to the side over there. So GIH right here is a right angle. Let me use my blue here. That's a right angle. And this would be a right angle right here. And that would be HFG. HFG. Okay, and that's the definition of an altitude. Okay, so just remember when an altitude comes down, it comes down straight, hitting the opposite side, creating right angles. Alrighty, step number 3. That also means, since they're right angles, they are also congruent to each other. That's just the definition of right angles. All right angles are congruent. They're 90 degrees, right? So far we have two parts that are actually proven congruent. We need one more part. Let's see what the given information is. Angle HGF is congruent to IHG. We're going to go find that so we can make sure we know where that is. So HGF, and IHG. All right, let me see here. GIH, that doesn't make sense. And IHG, HGF, sorry, HGF, here we go. And I'm going to use a different color for that. I'll use red. I was looking at number 3. So number 4 says HGF. HGF, which is, no, HGF, over here, but that's already marked. All right, HG. Well, let me look at this. So HGF, hold on. HGF and IHG. IHG are congruent. These two are congruent. And, okay. Oh, yeah, because I already marked them. Okay, that's where I was getting confused. I marked them up here already. So that was these ones in pink over here. I'll color them in so you can see them better. But these pink ones on the ones that I drew out here, right here, those two are congruent. I put those in there a little bit prematurely. I should have waited till I listed the step with you because I was trying to figure out how did that turn out that way. But anyway, okay, so now we have, think about it, we have an angle. I'm going to write right here. We already have proven one corresponding angle set, 2 corresponding angles, I should say, congruent. We have this one that was given, so there's another angle. We need one more part of the triangles to prove congruent, and then we'll have the 3 things that we need to say those triangles are congruent. So let's look at GH. They're saying they're sharing a side GH. Is that true? I think it is. Let me mark it. Here's GH. When I pull them apart, here's GH. So let's look on the diagram. Let me use a different color. I need something a little bit darker. We'll use blue. GH, right here. GH is being shared by both of those triangles. So it is true that GH is congruent to GH, and that's the reflexive property. Remember, if they share a side, we call that reflexive because it's like looking at each other, but it's the same. And so therefore, we have our 3 parts. We have angle, angle, side. So triangle GIH is congruent to triangle HFG by the angle, angle, side shortcut. And therefore, we can now say that the other side in the triangles, GI, which is this one here, and FH, which is this one here, the 2 pink ones, are in fact congruent. That's what we were trying to prove. So now we can say that due to the CPCTC, we have proven those 2 sides congruent. By the very end, by doing all those steps, the final step says we use the corresponding parts of congruent triangles are also congruent. So that is that proof right there. Okay, so I'm going to go ahead and end this one.